we got a bunch of stuff that will become more of common terminology that we're going to be using. So we're going to be defining things kind of on the fly as we go into it. The first part of today's things is just going to be all about what are called arcs and central angles. Tomorrow we'll talk about something completely different with arcs that are called arc lengths. It's a whole other ball game with those. But what I wanted to just kind of show you, and I don't want you to write all this out yet, is that this unit kind of goes with a whole bunch of different vocabs. So I know that on this list of things here, you know 80% of it. You know what it, well, I'm assuming you know what a circle is. How do you define a circle officially? You know? No. Exactly right. Exactly right. A circle is defined by a set of points that are equidistant to a center. And the reason that that happens is because when you have a circle, please don't pop your gum. When you have a circle, you've got all these things called radii. Radii are all congruent. Radii are just segments. And those segments have endpoints. One endpoint is always the center, the other endpoint is always on the circle. That's how the circle is defined. Now, the center of the circle is the point at which all the radii go from. The diameter is the segment that goes from side to side through the center. The radius is the center to side. These are things you guys all know. You also know this thing called circumference. You know how pi works. But then the rest of it here is where you start to get into some of the wishy-washy things that we're not quite sure of. So what I want you to do is I want you to draw, What I want you to do is draw a circle, and I want to define this. I want you to draw a circle. I'm going to call it circle Q. Circle Q. Q, when they call it circle Q, that means Q is the center of the circle. It's close-ish. And then I want you to draw in segments AE and segment DC. We're going to call them diameters. Okay. Draw those in, and we're going to call those both diameters. Now, what does a diameter do to a circle? It goes all the way through, but what does it do more specifically to the circle? It cuts it in half. You okay with that? Now, what's the term for something that's half a circle? You guys remember? Sorry, I yelled it out as I was drinking water there. You guys ever? Not a half circle. True, but you guys remember this thing called a semicircle? A semicircle would be a circle that's been cut by a diameter. Half a circle if you want. Now, if there's 360 degrees in a circle, how many degrees would then be in a semicircle? 180. Semicircle has 180 degrees to it. Again, probably stuff you've seen. You just kind of forgot that you've seen it at some point in time. There's a couple other things we're going to look at here. There's another term called a central angle. This thing called a central angle. A central angle is an angle whose vertex is at, guess where? The center of a circle. Whew. I'm telling you, we're trying really hard not to math too much for you right now. Central angle, it's an angle whose vertex is at the center, and the sides of the angle are made up by radii. Obviously, the sides of that would be radii. For example, in this one here that we have. AQC. Radii is just, it's rad with 2 eyes. No, bro is BRO. That's AGHH. Anyway, central angle. Angle at the center. The angle at the center intercepts a portion of the arc of the circle. This is called an arc. An arc is a segment that's on the circle. We'll get to that in a second. Like I was saying, I got a couple of terms here. An arc is a segment for example, I would write it as AC with that little curve over the top. That means it's an arc as opposed to a segment. Should draw this full page. There. All right. Now, that central angle runs into an arc. So we say that it intercepts an arc. So the intercepted arc of an angle, their measurements are always the same. So if the measure of the central angle here was, I don't know, 110. If that's 110 degrees, that means that the arc that it runs into has to measure 110. Okay. If that measures 110, and obviously if we said that AE was the diameter, how much is left for that angle there for CQ? 70, which means arc CE is how much? 70. Hey, aren't these vertical angles? Exactly. Oh, aren't those vertical? The idea of vertical angles within circles and stuff, it still holds true. Okay. Arcs, the measure of an arc will always equal the measure of the central angle that creates it. Okay. The measure of an arc always equals the measure of the central angle. Okay? Those are always going to be the same. Which means, how many degrees do you have to work with for arcs? Total. 360. And then arcs have their own definition. You have what are called minor. You have a minor arc and a major arc. It's really, really easy to work with. Minor arcs measure less than 180. What do you think majors are? What is it called if it equals 180? You just semicircle. As the arc equals 180. Okay. Now, the only weird thing that happens then with arcs and major arcs and minor arcs or semicircles, it's usually dependent upon the number of letters that you have. So if I go back and look at the diagram we just drew a second ago, if I say AC, arc AC, is that going to be a major or a minor arc? Minor. How many letters did I use? 2. If I say arc ACD, where do I start at? I go from A through C to D. When I use 3 letters, it's telling me that I need to go through that midway point all the way around. It doesn't have to be halfway through it just tells me direction. Okay? So minor arcs are generally 2 letters. Major arcs are usually 3 letters. Same thing with semicircles. They usually use 3 letters for these as well. I'd say 3 letters. Yes, ma'am. Mm-hmm. For either one, the measure of the arc for a minor arc is going to be less than 180. The major arc is measure of that arc is more than 180. And if it equals 180, it's a semicircle. It just thinks that there's no other way to write arc. I can write AC or RK. Okay. Not stopping something. Just going to show an example. All right. It's not bad. It's really easy. It's real quick here. Yeah. Come on. I haven't gotten there. Okay, haven't gotten there. Now, a lot of times with circles, especially with arcs and stuff that we start out with, you're going to be given information. In this example, we have circle O, and CA is a diameter. If I say that we have circle O and CA is a diameter, there's enough information with just that and what's given to me to figure out all the missing pieces. I can find the missing arcs, and I can find the missing central angles. And then I can go about and label a couple of the pieces. Now remember, if you get rid of just the circle itself, if that's 32 degrees, what does this side have to be? How much? 148, because it's got to add up to equal 180 degrees. Okay, same idea over here. If this much here then is 58, what does this part have to be then? Next time you spit it out. Okay, it's the same premise. You've dealt with all of these problems before. The only thing that's different is that there's curves going around. Okay? You do all of the exact same style math. So if we're looking at this, I wind up with this being 148 and this being 122. Well, couldn't I just figure out quickly by figuring out what is the measure of BDA? If I do BDA, what would I do? Just add them up. You can add some stuff together. Now, if I'm going BDA, I'm starting here. I'm passing through D on my way to A. So I could add 32, 58, and 122. Or, what aren't I using? Right, so couldn't I just take 360 and back that out? There's a couple of ways of going about it. The idea here is that when you're working with arcs, you treat it just like you would angle addition, segment addition, segment subtraction if you had to do things like that as well. The only thing is that you know everything has to add up to equal no matter what. Because there's only a finite number of degrees within a circle. Always 360. It never changes. Now, one of the ones that I don't want you to draw out, let me get it more complicated. For example, take a look at this as it's coming around. And I want to pay attention to a couple. Hey, dear. For example, on the first page, on that first page side, you've got that second diagram. It goes through questions, I think, 9 through 18, I want to say. If you look at that, it tells you that you have, in the description, it talks about having a couple of diameters. And you're given a couple of central angles. Now, whenever you have these types of problems, and this is very, very common for these types of units, you never answer the questions one at a time. It wastes too much time. You know that you have a circle. You know you have diameters, QS and PR. So I know that these three angles have to add up to equal how much? 180. So what's missing? Well, what's 64? 180. 64 and 42 would be 108. No, 106, sorry. Okay? That gets you there. Now, go back a second. It says that you have PR and QS are diameters. Means they intersect at some point, right? Don't two segments that intersect create vertical angles? So where this part here has to be here. Which means this side's going to be 64 and 74, which is 138. Sorry. I was adding the 64 and 42. Wait, no, that doesn't work. Okay. Now the idea here is to start with something simple like that. Excuse me, and then work your way out, because now it's easier to answer the questions. So take a minute and figure out those questions. You just did the work. This is the kind of math that we're doing today. Real simple stuff. Yes, sir. Yeah. It tells you the direction to go through. Yes. No. We're just doing a couple of these. I just didn't want you guys. We just wanted to try a couple of these. Yes, sir.
So one of them is R and S.
Yeah.
So basically minus.
Remember, minor arcs are 2 letters, and whenever you have 2 letters, it always means the shortest distance. Oh, I didn't hear the Q part. So yeah, if it's RQS, then I would do 360 subtract the 42. Yes. But if you already have 2 letters, it's always implied that it's minor, and it's the shortest distance between the 2. Okay? Sophie, you're going to ask something? Yeah, take a second. Try those real quick. We'll check them here in a minute. No, we got it. I'm picking and choosing off some examples off of here to work from. Okay. What's up? How much was yelling at you? What's wrong? Ladies and gentlemen, come on now. What? I just wanted you to do those, yes. I didn't say anything else about anything else. No, because you don't know how to find arc length. I'm not doing any of that. I don't specifically said just do these. Now, you can do the rest of them. I don't care. It's not homework, so it's just what we're doing in class. All right, what do you got for PQ? TPS. TPS. Going around, remember, it goes from T, P, back around to S. The easiest way to do that is take 360 back out 74. You had what, 286, you said?
Yep.
Okay. RQS, again, do the 360 and back out the 42, and you get, there you go. PQS, that'd be your 180, add the 42, so 222. PS, remember, when you have two letters, it's the shortest distance, and they're talking about minor arc. That's when you have your 138. Same thing with ST. We already had that 174. RT was your 74 and 42, so that's 116. QR, we had to get that one earlier. That was 138. And then about what? Uh, 74 and 64. Shortest distance between 2 points. 2 letters means the shortest distance. Then TQR, that's your 180, add the 64, so that's what, 242? Right? Wait, 180 and 64, 86, 240, yeah. Easy. I was about to write that, yes. Yeah. Yeah, and then lastly, you have guys, when you have PTR, yes, it's telling you to just go from P, go past T to R. That means your endpoints are at P and R, which means it is 180. Semicircles usually are 3 letters, but every now and again you will see just PR. If it's PR, it just means it's, well, what's the shortest distance to get from P to R? Well, no matter which way you go, it's always going to be 180. Okay? So that's the weird one. Take a look at the problem at the bottom here. But if you look at it, what doesn't it have? Ladies and gentlemen, I've had it. You've been in class, you're back. I get it. Quiet. We have a lot to get through. Can't handle it? Sorry. The problem's at the bottom there. It says 2 diameters of the circle are blah and blah. Find the given arc measures if one of the arcs is 35. What doesn't that set of problems have? Picture. Which means you have to know how to draw pictures and fill in blanks. This is extremely common the further we go throughout the rest of the school year. Nope. You don't need it. You guys done? I just had this conversation. It's not a difficult concept. Again, you have to know how to label it. It tells you have a circle T. Well, T is the center, so you put a T in the center. Then you have diameters P, Q, and RS. Does it matter where you place them? For the first one, it doesn't. First one doesn't matter where you put it, because as long as it goes through the center, it's a diameter. So if I put it going through here, P, Q. Now the next one matters where I put it, because it tells you that you have another diameter of RS, but the measure of the arc from P to R is only 35 degrees. So that means I got to figure out where am I going to place R. If I place R, I got to figure out where do I place it on the circle so that that next statement is going to be true. So PR, is that 1, 2, or 3 letters? 2, which means is it going to be a minor or a major R? Minor, so it means it's going to be less than 180. So will point R be closer to P or closer to Q? Closer to P. Now, does it matter if it is, in this case, above it or below it? Nope, it doesn't matter at all. So if I place it here, because the way it's out of the way, what I need to do is figure out what's approximately 35 degrees. Well, if I went straight down here, how much would that be? 90. If I cut that in half, it would be, so it has to be a little bit closer in, maybe here-ish. That's kind of what you're doing, guys. You're approximating where something would go. Yes, sir. I see what you're doing. You just labeled it out. It's not technically wrong because it's not to scale. But it's when it gets into it, if there's more information, you might start thinking, oh, that's 90 degrees. It's got to be the other way around. That's why you got to be careful. That's why even if it's just off a little bit, it's a little bit cleaner. And then you just draw through to the other line, your other segment. So, say what? This was 35? What makes the central angle then? If the arc is 35, what's the central angle? John, you were just saying, what's PTS? Which gets you 35, which gets you 145. Okay. That's the idea with some of these styles of problems where you're going to come across where you have to fill in blanks to draw pictures to answer. Do the problem at the top of the next page. It's very similar, and solve those through. Yes, sir. It tells you the direction. You start at P, goes through R, then Q. Yep. When you have 3 letters, it tells you the direction to follow in your picture. So you just follow it through. That's how you set those things through. Enough. Hey, what's up? Mr. Your car's being towed. So if you've got one of your diameters is JK, and the next one has a diameter, the other one has an arc JM, it's 165. It's still a minor arc, which means it only needs 2 letters. But now, is M going to be closer to J or closer to K? It's going to be closer to K. Does it matter if I put it above it, or I should say to the left of it or to the right of it? I'll just put it here-ish. Similar. So if that was 165, what's left? 15. And so on and so on. Now, excuse me. The big thing that people will screw up on this stuff is that, it's kind of like what you were doing, Derek, where a lot of times when you're following letters, you forget what direction to go. The lettering tells you specifically which way to, where to start and where to end. The middle letter, if there is one, tells you whether you're going around something shorter or closer. So if I say JL, I write 4 here. If I say JL, that means I'm going from here to here. 15. J past M to K, well, that's a diameter. Okay. If I'm going from J to L to M, that was 180, add the 15, and you got your, what, 195? And then KLM means I'm starting at K, going past L, and ending at M. Well, I could do the 165, 15, and 165, or can I just take 360 and subtract 15? It works all the same. Okay? If you do it that way, what is it, 345? Super, super easy to work. The other little bit from really all we'll have time to get through for today is this idea of what's called congruent arcs. Do you guys agree that these two circles both have 360 degrees? Okay. Do you also agree that if I place this as a center, say that that's 120, center, say that this is 120, are those two angles congruent? Yeah. Since those two central angles are congruent, that means that what is this arc here going to measure? Oh, I'm sorry, I'm on the wrong side. What is this arc going to measure? 120. Okay. What does this one measure? That's also going to measure 120. Now, this is where congruent arcs, how it's defined, how it's used in sentences, if you will, is different. These two arcs would be the same because the central angles are the same. Their length would be different. Okay? Think of this as on a track. The inside track is a shorter distance than the outside of a track because the inside line is a shorter radius. Okay? So the length from here to here is different than the length from here to here. It's obvious when you start really thinking about it. That's why you could have congruent arc measures, but not necessarily congruent arc length. Does that make sense? Well, if you think about running on a track, if you're running on a track, thanks. It's terrible. Each one of those lines, it's still running on a track, right? You're running on a track, right? Which track is the shortest to run around? The inner one. Now this one is, who's going to get to the finish line first if they stay in their lane? You. This is why if you're on the outside line, no, this is why things are staggered for starting spots. That's why they're staggering them out, so that way each person is running the same distance. Okay? Does that make sense? Sir? Yeah. It's going to be out of the 360, but it's going to be dependent upon the radius. Bless you. Okay. Now, what I want to do here is on that same back page real quick, this is something really easy. Look at 36. How are you going to figure that out? What would you do to figure out the measure of each one of those? Well, you need diameter. If they're all congruent chunks. Or wouldn't it be just as easy just to count them all up?
That's not what I did.
Well, how many of them are there? 15. All right. If each one of them is going to be the same, yeah, they're all going to be 24 degrees. It's the idea that if you know that something's going to be congruent, if you know that something's going to wind up being congruent, if they're all set up like that, it's a matter of putting them through. This is how, like, Wheel of Fortune goes. You know that? You guys know Wheel of Fortune, right? Yeah. So when you have Wheel of Fortune, these things are actually called. Actually, do you know what these are called? These little chunks. Well, do you know what they're technically called of a circle? They're called sectors. Okay. A sector is defined by the angle and the radius. So it's a portion of the area of the circle. So each one of them has its own probability upon landing on it. Now in this case here, how many did you say there were? 15. So you have a 1 out of 15 chance landing on any one of them. So if I have 3 of them that are yellow, what's the probability of landing on yellow? 3 out of 15. So this is how probability starts going in here with shapes, which we'll do next week. Oh. Yeah, I got another couple of fill in the blanks out. Circles that we work with. Did I hear a bell ring? I didn't hear a bell ring. Did you hear a bell ring? No. Quiet. Come on now. Look, seriously, guys, this is not boding well for the last 7 or 8 or so weeks for you guys. Let's continue like this. This will not bode well at all. Okay. So, obviously, we did not get to this thing called arc length. It's a whole nother setup. It's a lot of calculator work, so make sure you've got your calculators ready to go tomorrow. But on the one, and then, now my suggestion would be to do 7 through 14 first on this side, and also on the other part, do the 7 through 12 first. I would do those first. Those are easier, okay? Because the first 2 sections talk about a bunch of algebra. Well, if you look at the diagrams for either one of them, you'll notice that you've got 3 of the angles in a row. And it just so happens that EB happens to become a diameter. Which means those 3 angles have to add to equal how much? 180. Diameter is 180. So then you'd have to figure out what x is, and then figure out what each of the angles is and work your way out. So those other 2 sets will have a little bit more algebra at first, but solve for all of the central angles, or arcs, if you will, before you try to answer any questions. It makes doing these problems easier. You have to believe me on this, okay? So don't just go, I don't know how to find the angle ARE. I'm going to say, did you solve for x yet? No. I'm going to yell at you and make fun of you and stuff like that, okay?